So good evening everyone. So maybe we can start now since some folks have joined in. Yeah. So first let us speak about how has this course been up to this point. Like is the difficulty progressively increasing or is it manageable, and does the course content need to change, like readjusted and so on? Are there any comments on this regard?
हेलो सर। मुझे सेंसिटिविटी में थोड़ा प्रॉब्लम हुआ था।
अच्छा, सेंसिटिविटी में प्रॉब्लम हुआ था। ओके ओके। Was that covered in this week or an earlier week?
व्हाट सर?
सेंसिटिविटी टॉपिक ये वीक 4 में था या पहले का था?
वीक 4 में ही था सर। असाइनमेंट में भी क्वेश्चन आया हुआ था सर, और मुझे
अच्छा,
टॉपिक समझ में नहीं आया सर।
ओके ओके। Which book are you following for control systems?
नाइस विले का सर।
हाँ, तो नाइस में शायद सेंसिटिविटी का एक सेक्शन है ना, वो पढ़ा है क्या?
कौन सा सर?
नॉर्मल नाइस बुक में सेंसिटिविटी का एक सेक्शन है ना?
ये सर उसमें है, लेकिन पहले मैंने सोचा कि वीडियो लेक्चर के थ्रू पढ़ लो, लेकिन वो समझ में नहीं आ रहा था। लेकिन वो बुक में भी समझ में नहीं आ रहा था कि फॉर्मूला कैसे आया, उसका कहाँ एप्लीकेशन होता है, मतलब वो समझ में नहीं आ रहा था टॉपिक ही, तो उसको मैंने स्किप कर दिया।
ओके okay, so let us begin by discussing this week's question. So for this week I have primarily focused on stability and Routh-Hurwitz criterion to get to stability and stuff. I have not planned any questions of sensitivity, so we'll see how to deal with that. And so yeah, so let's get clear with Routh-Hurwitz and stability concepts first, then we'll go over to sensitivity. So I'll begin by today's question. Okay, so we have this system which gives output y of t, the red curve, for a particular input x of t, which is the blue curve. So from this information, what can be said about the system? Is the system stable? Is it unstable? Or can we say, can we conclude anything about the stability of the system, or can we not? So what do you guys think about it?
System is stable because output is bounded.
So you are saying that system is stable. Any other answers? So everyone agrees that this system is stable?
Yes, sir.
Okay. So can someone tell me the definition of stability in the Bibo sense? Bounded input, bounded output?
Yes sir. For any input, output is bounded होना चाहिए सर। कोई भी इनपुट देने को तो वो सिस्टम में स्टेबिलिटी रहेगा।
मतलब कोई भी इनपुट देने से या वो इनपुट भी कुछ एक टाइप का होना चाहिए? मतलब अगर मैं एक इनपुट ऐसा इनपुट दे रहा हूँ और सिस्टम आउटपुट भी ऐसा कुछ आ रहा है,
should also be bounded.
Yeah. So Bibo stability says that given any bounded input, the output that the system gives should be bounded. Okay. So what do we have here? We are given one particular bounded input, this curve, and for this particular bounded input, I am getting a bounded output. But that does not tell me that given any sort of bounded input or any sort, it does not guarantee that given any sort of bounded input, my system will give me a bounded output. Right? Like it may happen that for this system, I have an input of say this form triangular wave, and for that the output blows up at some point. That might happen. So we can only say that a system is stable if for every given bounded input my output is bounded. But on the other hand, if at least for one given bounded input, for one, I have that the system is giving me an unbounded output, then I can say that the system is unstable. Right. So every bounded input gives bounded output and one bounded input gives unbounded output. So this will ensure that my system is stable and this will ensure that my system is unstable. So but from this particular graph, what we have is one bounded input gives us one bounded output. So I cannot say anything about the system stability. I can neither claim that it is stable just from one pair of input-output pair, neither can I say that it is unstable because the given input-output pair are both bounded. So the answer is we cannot conclude anything about the system stability from these two graphs. Is this reasoning clear?
So once again about please, sir.
Yeah. Sorry, what did you say?
फिर से एक बार बता दीजिए.
So basically what I am saying is, in vivo sense, the definition of vivo stability for a system states that given any bounded input, if my output is bounded, then the system is stable. But that the stability, this definition covers the, so given any bounded input means that for all the bounded inputs that can exist, for all such bounded inputs, my output has to be bounded. Then only my system is stable. So that even if only one bounded input gives an unbounded output, then my system is unstable. Okay. So if for all bounded inputs my output is stable, bounded, then the system is vivo stable. If even for one bounded input the output is unbounded, then my system is unstable. But here we are given only one pair of bounded input and bounded output. So that won't guarantee us anything about system stability. Is that clear now?
जैसे क्योंकि यहाँ पर एक बाउंडेड इनपुट दिया जा रहा है, इसे तो मैं बता नहीं सकता कि सिस्टम.
But अगर if in this graph we had that for this bounded input the output was something unbounded, then we could say that this system is unstable. Yes, but for this particular given thing we cannot claim anything about the stability of the system. So stability of the system cannot be determined from only the given input-output pair. Is that correct?
Yes, sir. If output is bounded for any input, then we say system is stable.
Correct.
कर सकते हैं.
If output is bounded for any given bounded input, then system. Then question क्या था? Output is bounded for any given
input.
I mean, yes, if such a system exists that you give any given input. So suppose there is a set that contains all possible inputs, and no matter what you give to the system, my output is bounded. Then this is clearly a stable system, because from all possible inputs, bounded inputs are only a subset of it, right? So if all possible inputs give bounded outputs, then bounded inputs will obviously give bounded outputs, correct?
Yes.
Yeah. So yeah, that is the essence of vivo stability. Given every bounded input, my output should be bounded. Then only the system is stable.
If two input signal, मतलब दो को सिग्नल दिया गया सर, दोनों सिग्नल इनपुट जो है बाउंडेड है, तो आउटपुट भी मेरा बाउंडेड है, तो क्या वो सिस्टम भी स्टेबल होगा?
नहीं, हम बोले ना कि for you have to check that for every possible bounded input, 2, 3, 4, 5, 1000, 10,000 जितने भी मिले, you cannot claim that the system is stable because there might exist a bounded input which when given to the system will yield an unbounded output. Clear?
Yes.
So any other doubts in this concept of how we get to the bounded input, bounded output stability definition? No? So we can move forward. Okay. So now we have the system. A system has an open loop transfer function as given by g of s. Is the unity feedback closed loop system stable? So what do we do with this? We will try to use the Routh-Hurwitz array to determine whether the closed loop transfer function has any poles in the right half plane or not. Correct. So first let us find out the closed loop transfer function. That will be given by g by 1 plus g. So come on, one of you tell me what should be the closed loop transfer function with unity feedback.
2x के पावर 2s4 plus 5s cube plus x square plus 2s plus 1. This is a characteristic equation. 1 by 2. 2s4 plus 5s square plus 5s cube plus s square plus 2s plus 1. Yes.
Correct. Yeah. So this is the closed loop transfer function. We want to find the number of poles, like if this characteristic equation has any poles in the left half in the right half plane or not. So how we can do that is by the Routh-Hurwitz array. Okay. So okay. So someone apart from Abhishek help me fill this up.
Yes, sir. S4 में
one. Hey, Abhishek, wait. Apart from you, you are the only one answering. So anyone else? How do we fill up the Routh array?
In the S4 row, sir,
Yes.
we write 2, 1,
1.
and 0.
Why 0?
No, sir, 1, sir, 1.
Correct.
2, 1, 1.
And
And in
here
the S3 row, 5, 1.
yeah. No, not 5 1. Check properly.
5 2.
5, 2, sir.
Correct. So basically we fill the coefficients starting from the higher order in this way.
Yes, sir.
Correct? Okay.
Yes, sir.
So now how do we get to the next step? What should we here?
So cross multiplying it, sir. 5 into 1 minus 2 into 2 by 5.
Yeah, correct. So what we'll do here is
1 by 5.
we'll find the 5 into 1 minus 2 into 2 by 5. So this is 1 by 5. Now what should be in this place?
In this 5 into 1 minus 0 by 5, that is 1.
1. Correct? So then similarly what should be the next thing?
2 by 5 minus 5 by 1 by 5.
Yeah. So what is this value?
This is minus 23.
Minus 23.
Minus 23.
Minus 23. Yeah. Correct. Yeah. Then this place will be 0 because these two are zeros. So then next this place, here what do we get?
Minus
1.
23 minus 1 by 5 by 23.
One, sir.
Yeah, 1. Correct. So here how many sign changes can we see in the first column?
2, sir.
2 sign changes.
So here and here. So starting from the top of the column, I see that 2 to 5 there is no sign change, 5 to 1 by 5 no sign change. Then here I see one sign change and consequently here again I see another sign change. So in this closed loop transfer function I see two sign changes. So what does that mean? That means I have two poles in the right half plane, two right half plane poles. Now what is the order of the transfer function, the characteristic equation? It is fourth order. So we should have four roots, and since two are in the right half plane, the other two will be in the left half plane. Correct? Is this part clear?
Yes, sir.
Yes, sir.
Okay. So we'll move forward. Okay, now we are given a system has an open loop transfer function as given here. What is the complete range of K for which the unity feedback closed loop system is stable? Yeah. So again, this is very similar to what we did in the last question. We are given a transfer function. We want to find out whether it is stable or not. Just that in the transfer function, now we have one parameter K, which can take all possible real values. Right. So we want to find out for what values of K is this given transfer function stable. Right. So what we'll do is we'll follow the same process. First, tell me what is the closed loop transfer function.
K into S plus 2
K into S plus 2
by S cube plus 2S square plus S into K minus 3 plus 2K. S into K minus 3 plus 2K.
Yes, correct. So this is the closed loop transfer function which we can find by G by 1 as G by 1 plus J. So everyone is clear with this? Anyone has any different answer?
Yes, sir.
Yeah, okay. So now again what we do, we want to find out whether this characteristic equation has any poles in the right half plane. Right. So if this has any poles in the right half plane, then the system will be unstable. So we want K such that there is no pole in the right half plane. That is, all the poles are in the left half plane. So when do we have no pole in the right half plane? If there are no sign changes in the first column of the route array. So we want a K such that in the first column there are no sign changes. Correct. So we'll write that. So as per last question, we'll fill it up. 1, 2, K minus 2, 2K. Right? So yeah, now help me fill this one. What should go here?
Minus 3 zeros.
Minus 3.
Minus 2. Okay. Then what should go here?
Zeros.
0.
What should go here?
2K. 2K.
Here 0. So now tell me, under what conditions for K can we say that the system will be stable?
For no values, sir, because there are sign changes.
Correct. So as you can see, if you move down this column, here there is no sign change, but as I reach here, I see one sign change, and so now it doesn't matter what the value of K is. It can be negative, positive, whatever it might be, but there is a clear sign change here. So no matter what the value of K is, this sign change won't change. Like this is 2, this is minus 3. That won't change no matter what the value of K is. Correct. So what that means is, no matter what K I choose, this closed loop system is unstable. Okay. So this particular system that we have, we wanted to see if we say, so how you would want to check this is, suppose you have some plant. Okay. Let's say we are given plant has this transfer function, right? So if the plant has this transfer function and say I am using some kind of a controller, right? Say that is of the form some ks plus some other constant kd, kp, right? Then I want to see whether this controller that I am using will be able to stabilize the system or not for whatever value of k I might want to choose. Okay, so what we see here is, if we use a controller of say this form k into s plus 2, then no matter what gain value I choose for k, whatever gain value I choose, this system will be unstable. So this is not a stable controller design for this given plant. So that is the usual way, like that is the intention behind asking questions like this, that what is the complete range of k for which the unit feedback closed loop system is stable. So why would you want to know that? Because you might want to be designing a controller for the system and you want to test whether this controller will be able to stabilize the system or not. Then further, if that is possible, you would want to find out a value of the, like a range of the gain which will allow you to do that. Okay, is that clear?
Yes.
Yeah. Okay. So we'll move ahead to the next question. Okay, we have a big one here. For the closed loop transfer function as given in this, how many poles are there on the right half plane and how many poles are there on the left half plane and how many on the j omega axis? So we'll first make a route table. S plus 5, S plus 4, S cube, S square, S square. Yeah. So now first I fill the given things. Yes. So now another thing. You know that. Yes, Sashi, are you saying something? Okay. So now you know that. I'm sorry, just 1 minute. Yeah. So what I was saying is, I guess so yeah. Now if you see some row like this, where you have some -2, -6, -4, you see clearly that there is a common factor 2 in all of this, right? I can divide each of these by 2. So when I do that, effectively the computations of the route array won't change. Why? Because when you find the next place, what you do is you multiply this, then divide by this, right? So if you if I divide this by 2 -1, -3, -2, then -1 into 3 -3 into 1. -1 into 3 -3 into 1. So when you do that, you can see that since you are dividing a common value from this term and this term, like originally they were -2 into 3 -6 into 1. So what you did was you divided a common thing from this term. So that won't effectively change this determinant, negative determinant value. Correct. And when you further divide it by this term, say -2 or -3, -1. So -2 here and -1 here. Yeah. So when you do that, you are just scaling the value, but the sign will remain the same. Correct. So what you get here will be some scaled value of what you would have gotten without dividing the 2, but the sign won't change. So for our purposes, we are only concerned with the sign of the columns, like terms in the column. So for that, it won't matter much, right? So to ease our computations, what we can do is we can easily divide this row. So now someone help me with finding the values in this S cube row.
Yes, 0, 0, 0.
Yeah. So you can see that what we get here is an entire row of zeros. So you know, when we get something like that, we want to find a auxiliary polynomial P of S, and that is given by this row, which is minus S power 4 minus 3 S square minus 2, right? And to obtain this, the like row values of S cube, what we'll do is we'll take the derivative. So that will give me minus 4S cube minus 6. So I can write this as minus 4 minus 6. But again, you see that these are also commonly divisible by 2. So I can further divide minus 2. But note one thing, that no matter like how much you scale up or down, but you should not multiply or divide by a negative number, because that will change the sign and that will change the results drastically. Okay. So,
सर
yeah.
इस 4 में जो रो जो भी कॉलम में नंबर है उसको नेगेटिव से जो टर्म है उसको कॉमन लेके हटा तो सकते हैं.
हाँ वही बोला ना, नेगेटिव से हटा सकते हैं, बट वी कैनॉट डू दैट. व्हाई? बिकॉज अच्छा ठीक है, सपोज वी हैव 1 3 2 एंड देन I did something here. I got 1 3 2, right? So resultant will also be 0 0 0. But and when I take the polynomial, what I'll have is 4 6. So here you see there is no sign change coming. But in actual computation, you originally had minus 2, right? But if you take minus out and divide it, then you see no sign change there. But in reality, there is a sign change which denotes the existence of a right of plane 0 root. But here, if you remove that minus 1 and divide it, then you will, at the end, when you see the row theory, you will see that there is no sign change. So this is a stable system. Okay, so you can divide by any positive value, but not in neither 0 nor any negative value. Okay. So
कल की क्लास में सर बोले कि जो भी माइनस होगा तो माइनस लेकर हटा सकते हो.
जो भी माइनस होगा माइनस लेकर हटा सकते हैं. ओके ओके, आई विल टेक
कल का ऐसा ही सेम प्रॉब्लम था सर, जो कि माइनस को एलिमिनेट कर दिए थे कॉमन.
वो प्रॉब्लम क्वेश्चन है क्या?
यस सर था सर, वो स्लाइड में.
अच्छा ठीक है, ये प्रॉब्लम सॉल्व कर दियो, वो क्वेश्चन ट्राई करता है. From what I saw by trying a few questions was, if we change the sign, we will have a problem. Okay, but yeah, we can check that question and see. Yeah, so for now I am not dividing by minus. Okay, I am just keeping the minus, but I am scaling up and down the things. So I have P. So I obtained dP by ds and found what the row value should be for S cube row. Now then I continue with the usual way. Now someone help me finding this position. What should it be?
Nine by 2.
Okay.
Minus 2.
So there is minus 2 into minus 3 minus 3 into minus 1.
Sorry, 3 by 2 minus 2.
Yes. So minus 3 by 2, and here what do you have? Minus 2. Correct?
Yes.
Yeah. Then here you can get minus 3 by 2 into minus 3 minus 2 into minus 2. So you will get minus 1 by 3. This will be 0. Then you will get minus 4. Can someone verify these values?
-2 सर SGO के पास.
Okay, yeah, like, okay, like this you can also write -1. Yes, because this is 4 and you can divide by 4 and you'll get -1. Okay, so yeah, now since we got a row of zeros, we know that that signifies the existence of an even polynomial as a factor. Basically, when you have a term like this s4 s square plus 1, right, only then will you get, so when you write this in the rows array, you will get 1 0 1 0 1 0, right? So when you have an even polynomial or an odd polynomial, that is a polynomial with powers of either only in even or odd numbers, then only you will get a row of zeros. And this happens, that is, we get an even polynomial only when roots are of this term fashion. Like I have either 2 roots like this, okay, 2 roots like this, or 4 roots like this. So I get an even polynomial when there is a symmetry of the roots about the j omega axis. Okay, only then do I get a entire zero polynomial. So see that if you get either the blue case, this 2, or the black case, then your system is unstable because you have right half plane zeros. Now the only case where it is not unstable is when you have this thing like a pole of multiplicity 1 on the j omega axis. Here you have like the system will be marginally stable. So when you have a row of zeros, the system is either unstable or at best marginally stable. Okay, and everything below this row will give me the number of poles, the information about number of poles in the this thing. What do you say? So the auxiliary polynomial that we got, P of S, that is the even polynomial which is a factor of this entire thing, and everything below that row will give me the results of this even polynomial, which is the auxiliary polynomial. That is, everything below this will tell me how many poles are there on left, right, or imaginary axis for this polynomial. Okay. So here you can see there is one sign change. So there is one right half plane zero, one right half plane pole. Then you can see that below here there is no further sign change. Okay, so there is no further sign change. So there are no right half plane poles in the auxiliary polynomial. No RHP poles in P of S. But since we know that an even polynomial will arise only when poles are symmetrical about the j omega axis, so this polynomial must have all the 4 roots on the j omega axis. Okay, because if there is a pole on the left half plane, then there should be one on the right half plane by symmetry arguments for this even polynomial. But since there is no sign change, so there is no right half plane pole. So no right half plane pole means by symmetry of this even polynomial, no left half plane pole. So all the poles will be in the j omega axis. So what we have is 4 j omega axis poles. Correct? So is what we did here clear to everyone? So we have 1 RHP, 0 LHP and 4 j omega axis poles. Yeah? Anyone?
Yes.
Yeah.
Sir?
Yeah, go ahead.
Sir, here sir, s to the power 4 से सर जो कि हम लोग एक्सिलरी इक्वेशन बना सर, इसलिए 4 पोल जो कि इमेजिनरी एक्सिस पे होगा सर।
हाँ मतलब ऑक्सिलरी मतलब हम बोल रहे हैं कि whenever we get a row of zeros, okay, if we get a row of zeros, that means that the characteristic equation is a factor of two polynomials, one of which is even. Okay, so when we get a row of zeros, I get one even polynomial as the factor. Is this part clear?
Yes sir।
Okay, now since I get an even polynomial as a factor,
सर अगर यहाँ पे सर साइन एक और बार चेंज होता सर,
हाँ
तो इमेजिनरी एक्सिस पे कितना पोल होता?
अच्छा ठीक है, अगर इधर और एक बार साइन चेंज होता तो वी आर सेइंग देयर इज वन राइट, मतलब सपोज यहाँ पर प्लस होता इंस्टेड ऑफ माइनस, ओके, देन बस एक बार साइन चेंज हो रहा है, तो एक बार साइन चेंज हो रहा है मतलब एक राइट हाफ प्लेन पोल है, तो एक राइट हाफ प्लेन पोल है तो क्या होगा ना, बिकॉज एवरीथिंग बिलो दिस denotes this even polynomial, right? So for any even polynomial, what I am claiming is poles will be only of this fashion. Either they will be like this, or like this, or on the j omega axis. So if there is one sign change, हाँ मैं बोल, अगर एक sign change है तो एक right half plane pole है, तो by symmetry there must also be one left half plane pole. So if there is one sign change here, then one right half plane pole, one left half plane, and the remaining will be on the j omega axis, that is two j omega axis poles. Okay.
सर लेकिन फर्स्ट पेपर में तो दो बार साइन चेंज होगा ना, एक 1 से -1 और फिर -1/3 से +1, तो दो रूट होगा ना सर राइट हैंड साइड में।
हाँ हाँ, दो रूट होगा टोटल पॉलिनोमियल का, ये जो ऑक्सिलियरी का एक रूट होगा, तो टोटल मतलब हम ये पार्ट देखें ना, इनसाइड दिस इज अ कंप्लीट सेपरेट पॉलिनोमियल which is given by the auxiliary polynomial. We are finding the roots of that polynomial after this line. Okay, so after this line there is one sign change, so one right half plane, by symmetry one left half plane, and the remaining will be on the j omega axis. Okay, now here
मीन्स ये सर कि एक्चुअली पोनेमिया से जो पहले साइन जितना चेंज हुआ वो उसका लेफ्ट साइड में होगा, लेकिन जो एक्चुअली के बाद साइन चेंज हुआ तो एक्चुअली पोनेमियल का जितना साइन चेंज हुआ वो उतना लेफ्ट साइड में।
नहीं एक मिनट, तो ऑक्सिलियरी पॉलिनोमियल के बाद जो भी है जितने बार साइन चेंज हो रहा है उतना राइट हाफ प्लेन में होगा और उतना लेफ्ट हाफ प्लेन में भी होगा। फिर ओके, आई जस्ट
Is it mandatory if there is one pole on the right half by symmetry, there should exist one pole on the left hand side?
Yeah, it is
mandatory that for every system it should happen?
Not for every system, only for a system where we get a row of zeros and after that line, okay, like here there is a sign change, that will mean only one right half plane, that need not mean any left half plane pole is there. But after the row of zero comes, one sign, like number of sign changes equal to right half plane, that is equal to left half plane. Okay, so here you see, yeah. So the auxiliary polynomial is of order 4, right? So and in the auxiliary polynomial, if you have one sign change, then you'll have one right half plane. Okay, by symmetry, one left half plane. From order 4, how many are remaining? 2. So there will be 2 j omega axis poles. Now, but for the entire thing is 5 order 5th. So one more pole must be there. So we will see in this part if there is any sign change. We see that there is one sign change. So this extra pole must be on the right half plane. So for this system, we will get 2 right half plane poles, 1 left half plane pole, and 2 j omega axis poles. Okay, is this clear? और इट गॉट
मतलब
So
सर
currently,
कि एक्चुअली पोने में कि जितना बार नीचे का जितना बार साइन चेंज हुआ उतना ही राइट साइड में होगा उतना ही
उतना ही
लेफ्ट
लेफ्ट में होगा, जितना बचा
अब
ऑर्डर उतना जियोमेट्रिक एक्सिस में होगा, बट ऊपर जितना साइन चेंज हुआ दैट इज जस्ट ऑन द राइट हाफ प्लेन, नथिंग एल्स।
तो
हाँ
मेरा क्वेश्चन ये है सर, जैसे कि S5 जैसे S4 पे है सर, वहाँ पे एक बार साइन चेंज हो गया सर,
करेक्ट।
एक पोल जो कि राइट हाफ प्लेन में होगा, ये तो कंफर्म है सर, और
हाँ,
टोटल यहाँ पे 5 पोल्स होने हैं,
करेक्ट।
तो फिर यहाँ पे ऑक्सिलरी इक्वेशन जो बन रहा है सर वो h⁴ से बन रहा है, यानी कि
हाँ।
जो बचा हुआ 4 पोल है सर,
हाँ
उसमें इमेजिनरी का कोफिशिएंट आना ही है सर।
हाँ, मतलब नहीं, अगर ऐसा हुआ होता कि सपोज ऐसा हुआ होता कि ये प्लस होता तो कितना साइन चेंज हो रहा है, एक इधर, तो 2 साइन चेंज हुआ, तो 2 राइट हाफ प्लेन पोल्स, बट बाय सिमेट्री 2 लेफ्ट हाफ प्लेन पोल्स होंगे, तो उस इवन पॉलिनोमियल में कोई जियोमेट्रिक एक्सिस पोल नहीं होगा, 2 लेफ्ट हाफ प्लेन 2 राइट हाफ प्लेन और एक राइट हाफ प्लेन इधर से, तो टोटल 3 राइट हाफ प्लेन 2 लेफ्ट हाफ प्लेन।
नहीं समझ पा रहे हैं सर, अगर यहाँ पे जो कि S3 पे सर 0 आ गया सर, 0 0 पूरा
ओके,
रो सर।
एक मिनट, मैं बस एक नए स्लाइड को ले जाता हूँ। या सो वो कॉपी कर लेते हैं पहले थोड़ा। बोलो, अब क्या डाउट है?
सर टोटल रूट्स 5 होना है सर, ये क्लियर है सर?
हाँ, लेट्स गो बैक टू द ओरिजिनल सिस्टम। टोटल रूट्स 5, करेक्ट,
यस सर।
टोटल रूट्स 5। हाँ, नेक्स्ट पॉइंट।
यस सर, नेक्स्ट पॉइंट ये सर कि उसके बाद फिर जो कि ये एक बार साइन चेंज किया सर, उसके बाद हमारे पास एक्सिलरी इक्वेशन जो कि आगे h⁴ थे,
हाँ,
उसके बाद अगर और एक बार नीचे कहीं साइन चेंज करता है सर,
हाँ,
तो मतलब रूट उसके बाद फिर कॉम्प्लेक्स आएगा, ये निश्चित है सर?
नहीं, कॉम्प्लेक्स आएगा नहीं। अच्छा एक मिनट, मैं तुम जो क्वेश्चन पूछे, सपोज ऐसा है, ठीक है, तो एक बार साइन चेंज हुआ, दूसरी बार साइन चेंज हुआ, करेक्ट, ये तुम्हारे क्वेश्चन को सेटिस्फाई करता है ये क्राइटेरिया?
यस सर।
ओके, तो कितना 2 साइन चेंजेस, सो देखो साइन चेंज क्लियरली इम्प्लाइज 2 RHP रूट्स, बट हम बोले कि ऑक्सिलरी इक्वेशन के बाद जो भी होगा, जितने राइट हाफ प्लेन में होंगे उतने लेफ्ट हाफ प्लेन में होंगे, तो 2 लेफ्ट हाफ प्लेन रूट्स, बट ऑक्सिलरी इक्वेशन का रूट ऑर्डर कितना है, 4, तो 2 और 2, तो ऑक्सिलरी इक्वेशन खत्म हो गया, बाकी बचा जो ऊपर का था, जो यहाँ का था, यहाँ पर बस एक बार साइन चेंज हो रहा है, करेक्ट, सो 1 राइट हाफ प्लेन रूट, सो टोटल 3 RHP 2 LHP।
सर अगर S4 से S³ में अगर साइन चेंज होता है तो किसमें कंसीडर किया जाएगा? विदाउट
S4 से S³ में साइन चेंज नहीं होगा, क्योंकि PS ये जो है -S4 -3S² -2, इसको जब डिफ्रेंशिएट करेंगे तो साइन रिटेन होगा, इधर इस रो से इस रो साइन चेंज नहीं होगा।
ठीक है,
ओके, सो इज दिस प्रोसीजर क्लियर फॉर एवरीवन?
यस सर, ये क्लियर है। एक मान सपोज करते हैं सर कि एक बार और में अगर वो 0 आ गया सर, सपोज करते हैं S1 के पास 0 आ गया सर,
S1 के बाद 0 आ गया इधर, सपोज
नहीं S1 के पास सर, S1 के पास पूरा रो 0 हो गया,
मतलब इधर पूरा रो 0 हो गया सपोज।
यस सर, तो फिर
तो
उसका
तब फिर ऐसा है कि सो उसका मतलब जो ये इवन पॉलिनोमियल है उसका और एक फैक्टर होगा जो कि छोटा एक इवन पॉलिनोमियल होगा। करेक्ट। बट तुम जो बोल रहे हो, हाँ या दैट मीन्स दैट, सो अगर इधर 0 0 आ गया मतलब कि और एक छोटा इवन पॉलिनोमियल फैक्टर है, तो इसको फिर ये लेंगे जो ऑक्सिलरी पॉलिनोमियल के हिसाब से, उसको डिफरेंशिएट करेंगे जो आएगा, फिर नॉर्मल प्रोसेस कंटिन्यू।
वैसे ही सेम जैसे पहले कंसीडर कर रहे थे अजोई पॉलिनोमियल की, उसमें इतना साइन चेंज हुआ तो लेफ्ट राइट वैसे ही सेम।
वैसे ही सेम। ओके, एनीवन हैज एनी डाउट्स इन दिस प्रोसीजर?
सर अगर बाई चांस हम ये रूल भुला गए तो ऐसा भी तो देख सकते हैं कि फर्स्ट रो में मेरा जितना बार साइन चेंज हुआ उतना बार मेरा रूट जो है राइट साइड में होगा, और अजोई पॉलिनोमियल को इक्वेशन को सॉल्व करके जो मेरा रूट आएगा फिर वहां से हम बता सकते हैं।
हाँ वैसे तो कर सकते हैं, बट वही होता है ना कि हम डायरेक्टली रूट कंप्यूट इसलिए नहीं करते क्योंकि पॉलिनोमियल कुड बी ऑफ वेरी लार्ज साइज। मतलब अगर 10th ऑर्डर का ऑक्सिलरी पॉलिनोमियल आ रहा है तो वो तो कंप्यूट करना फिजिबल नहीं होगा ना।
तो इससे यहाँ पर मेरा दो तो इमेजिनरी एक्सिस पर है, तो मेरा सिस्टम स्टेबल है कि अनस्टेबल, मल्टीपल पोल है कि नहीं है इमेजिनरी एक्सिस पर, वो कैसे मालूम चलेगा सर? ये तो जहाँ पर इमेजिनरी एक्सिस पर राइज होगा, लेकिन मल्टीपल पोल होगा कि नहीं होगा वो कैसे मालूम चलेगा?
नहीं, ये जो है ये बस सिमेट्रिसिटी जस्ट सपोज ऐसा है, सो सपोज लेट्स टेक s प्लस माइनस j होल स्क्वायर है, तो मतलब रिपीटेड रूट्स है, तो लेट्स सॉल्व दैट। ठीक है, ये अगर कुछ गलत करोगे,
जैसे आपने बोला सर कि दो रूट जो है इमेजिनरी एक्सिस पे होगा तो वो एक पॉजिटिव वो एक नेगेटिव, ये तो मालूम चलता है सर, लेकिन जब इमेजिनरी एक्सिस पर 4 रूट होगा तो मल्टीपल भी हो सकता है या अलग अलग भी हो सकता है, लेकिन वो हमको मालूम कैसे चलेगा सर?
नहीं मतलब कि अगर कहीं पर साइन चेंज हो रहा है, अच्छा नहीं एक मिनट, इस तरह मल्टीपल, हाँ तो वही एक एग्जांपल लेके चेक करते हैं। s से प्लस j स्क्वायर और s माइनस j स्क्वायर है, तो मतलब s स्क्वायर प्लस 1 का होल स्क्वायर है, तो s स्क्वायर 4 प्लस 2s स्क्वायर प्लस 1, ये सिस्टम है। ठीक है, तो इसका करेंगे, सो 1 0 2 0 1, ठीक। तो इसको क्या करेंगे, इसको डिफरेंशिएट करेंगे, 4s क्यूब प्लस 4s, तो यहाँ आएगा 4 4, तो 4 इंटू 2 माइनस 4 बाई 4, वो कितना हुआ 1, तो 4 इंटू 1 माइनस ये 1 फिर होगा, फिर ये 0 होगा। ओके ओके, तो इधर देखो फिर से एक रो ऑफ जीरोस आ रहा है एट दिस पॉइंट, है ना, तो S4 फिर अगर लेंगे S4 प्लस 1, हाँ क्यों इधर आ रहा है ना रो ऑफ जीरोस, तो उसका मतलब है कि ये एक इवन पॉलिनोमियल है, तो जो कि एक्चुअल में है एक फैक्टर s स्क्वायर प्लस 1, तो s स्क्वायर प्लस 1 को फिर डिफरेंशिएट करेंगे 2s प्लस सॉरी पहले 2s, तो इधर हो जाएगा 2, तो ये 1 हो गया, तो हमारा तो कहीं साइन चेंज नहीं हुआ। करेक्ट, सो आई गेस ओके, तो अगर रो ऑफ जीरोस आ रहा है और मोर देन 2 लाइक 4j ओमेगा एक्सिस या वैसा कुछ आ रहा है, मतलब सपोज इफ यू हैव 2j ओमेगा एक्सिस रो पोल, देन मल्टीप्लिसिटी 1 है। ठीक है, मतलब इफ 0 रो कम्स देन 2j ओमेगा एक्सिस, तो ऐसा होगा 4 होगा तो ऐसा ऐसा लाइक रिपीटेड
जरूरी तो नहीं ना ऐसा?
जरूरी तो नहीं है. ओके, लेट्स टेक अनदर केस वेयर से ऐसा होगा, एक इधर. ठीक है, उसका चेक करते हैं कैसा आ रहा है, उससे हमको पता चल जाएगा कि है या नहीं. करेक्ट. सो आई हैव, इसके लिए क्या होगा, सपोज एस प्लस जे एस माइनस जे एंड एस प्लस टू जे एस माइनस टू जे. ठीक है, तो ये होगा एस स्क्वायर प्लस वन एस स्क्वायर प्लस फोर. करेक्ट. तो इसका लिखते हैं एस स्क्वायर फोर प्लस फाइव एस स्क्वायर प्लस फोर. तो आई एम इरेजिंग दिस वन, छोटा कर लेते हैं.
सर अगर कोई इमेजिनरी एक्सिस पर रिपीटेड रूट नहीं है, 4, 5 है, तो सिस्टम तो मार्जिनरी स्टेबल होगा.
हाँ, अगर रिपीटेड रूट नहीं है तो मार्जिनल स्टेबल होगा.
नहीं तो मतलब इमेजिनरी एक्सिस पर रिपीटेड नहीं है तो मार्जिनरी स्टेबल हो सकता है ना, 4,
हाँ
5.
अगर इमेजिनरी एक्सिस पर रिपीटेड नहीं है तो मार्जिनल स्टेबल ही होगा. तो हाँ, तो क्या बोलते हैं, एस स्क्वायर फोर प्लस फाइव एस स्क्वायर प्लस फोर, ये हो गया हमारा पॉलिनोमियल फॉर दिस सिस्टम. तो इसको बनाते हैं एस स्क्वायर फोर एस क्यूब एस स्क्वायर एस वन एस जीरो.
इमेजिनरी एक्सिस पे सर रूट्स रिपीटेड है या नहीं है, या फिर सिस्टम अनस्टेबल है या मार्जिनल स्टेबल है, ये तो हम तभी चेक करेंगे सर जब हमारा 2 रो 0 आएगा सर.
2 रो 0 आएगा. 2 रो 0 क्या होगा, मतलब वो क्यों तभी चेक करेंगे
सर? इस कंडीशन में जाके चेक करेंगे हम इमेजिनरी एक्सिस का रूट सर. क्योंकि अगर एक बार एंटायर रो 0 आता है सर, तो हम तो ऑलरेडी उसको बोल सकते हैं कि ये मार्जिनल स्टेबल है सर, अगर कहीं पे साइन चेंज नहीं होता तो.
कोई जरूरी तो नहीं है सर पूरा रो 0 आ गया.
वही ना, अगर ऐसा केस हुआ जो देखे थे, इस केस में 4 मतलब रिपीटेड रूट्स है, एक इधर एक इधर एक इधर एक इधर, मतलब 4 रूट्स हैं बट रिपीटेड है. तो उसमें तो साइन चेंज नहीं हो रहा है ना, बट वो तो अनस्टेबल सिस्टम है ना, तो वो नहीं बोल सकते कि मार्जिनली स्टेबल है बोलकर.
तो चेक करने का एक ही तरीका है कि हमें रूट्स निकालना ही पड़ेगा.
वो देखते हैं, इसका देखते हैं, इस सिस्टम का. लेट्स ट्राई टू फाइंड आउट व्हाट द रूट्स आर एंड सी इफ इट इज डिफरेंट फ्रॉम दिस केस. ओके, सो ये तुम लोग भी ट्राई कर सकते हो. सपोज I got this polynomial for this system. So 1 0 5 0 4. तो इसको इधर होगा 4 प्लस 10, राइट. तो इसका मतलब 20 minus 10 by 4 2.5. और 2.5 25 minus 16 9 by 2. तो अच्छा, तो सी लुक एट दिस. ओके, तो इधर देखें हम कि सो फर्स्ट केस वाज कि 4 रूट्स हैं.
5 होगा सर, इंस्टेड ऑफ 18/5 से 8.
ठीक है, जो भी है पॉजिटिव है तो करेक्ट.
यस सर,
पॉजिटिव. हाँ, तो ठीक है, देखो फर्स्ट केस वाज 4 imaginary axis roots are there but they are repeated. Okay, so in that case what we saw was हमारा 2 बार 0 रूट आया था, 0 रो आया था. But on the other hand, when we have a system like this, then we see कि बस एक ही बार 0 रो आया था, 2 बार नहीं आया था. तो मतलब कि अगर एक बार 0 रो आ रहा है तो उसका ये हो सकता है कि जैसे हम देखें 2 राइट हाफ प्लेन 2 लेफ्ट हाफ प्लेन होके 0 इमेजिनरी एक्सिस रूट्स हो सकते हैं. अगर वो केस है तो क्लियरली अनस्टेबल है. बट सपोज सभी के सभी इमेजिनरी एक्सिस रूट्स हैं, तो क्या होगा कि उसमें 2 पॉसिबिलिटी हो सकते हैं. मल्टीप्लिसिटी ग्रेटर देन 1 वाले भी रूट्स हैं या फिर मल्टीप्लिसिटी इक्वल टू 1 वाले रूट्स हैं. तो जैसे हम देखें, अगर मल्टीप्लिसिटी ग्रेटर देन 1 है, मतलब मल्टीप्लिसिटी ग्रेटर देन 1 है, मतलब ऐसा एक पॉलिनोमियल तो होगा ही, x स्क्वायर प्लस 1 होल स्क्वायर, मतलब कि प्लस माइनस जे दो बार है, तो एक इवन पॉलिनोमियल 2 बार फैक्टर होगा उस ऑक्सिलरी पॉलिनोमियल का, तो मतलब कि नीचे जाके एक और बार भी एंटायर 0 रहेगा। बट वो केस नहीं होगा यहाँ पे, क्योंकि यहाँ पे टोटल जो है वो एक इवन पॉलिनोमियल है, और हाँ, तो उससे हम कंक्लूड कर सकते हैं कि सिस्टम अनस्टेबल होगा या मार्जिनली स्टेबल होगा। ये पार्ट क्लियर हुआ क्या?
नो सर।
ओके,
उसके लिए तो समझ में आ रहा है कि 2 होगा तो सिस्टम मतलब मार्जिनरी अनस्टेबल हम बता सकते हैं, लेकिन जब 4 होगा तो रिपीटेड भी हो सकता है, पॉसिबिलिटी 2 है ना सर, रिपीटेड हो भी सकता है और नहीं भी हो सकता है, तो उसके लिए मुझे रूट निकालना होगा, रूट का जो सोल्यूशन होगा उसके अनुसार हम बता सकते हैं। एक मेरे पास ये बस उपाय है सर, बाकी नेक्स्ट आप जो बताएं वो तो मुझे समझ में नहीं आ रहा सर, वो तो समझ में आ गया सर, 2 जो
हाँ,
से
मैं समझ रहा हूँ। लेट्स सी इसका, लाइक मैं जो बोल रहा हूँ कि आई चेक दिस अप एंड पोस्ट वॉट एवर द एक्चुअल करेक्ट आंसर इज, बट अभी लेट्स ट्राई टू रीजन इट कि व्हाट कुड बी द केस। मतलब व्हाट आई एम सेइंग इज, सपोज आई हैव अ फंक्शन लाइक दिस, अ पॉलिनोमियल लाइक दिस, ओके। इसका मतलब क्या हुआ, रिपीटेड रूट्स हैं, करेक्ट? तो रिपीटेड
यस
रूट्स हुए तो हम देखे इधर कि 2 बार 0 आया था, एक यहाँ पे 0 जिसको हम काट के 4 लिखे थे ऑक्सिलरी पॉलिनोमियल को डिफरेंशिएट करके, और एक इधर आया था, करेक्ट? सो आई एम क्लेमिंग कि अगर ऐसे मल्टीपल टाइम्स रिपीटेड लाइक एंटायर रो 0 आ रहा है तो सिस्टम अनस्टेबल होगा, क्योंकि ना उसके क्या बोलते हैं, मल्टीप्लिसिटी 1 से ज्यादा वाले रूट्स होंगे। बट इस सिस्टम में देखिए, हाँ हाँ,
ये रिपीटेड रूट हो गए तो
रिपीटेड रूट्स होंगे, हाँ। बट इस सिस्टम में देखें कि एक ही बार 0 आया, फिर उसके बाद और 0 नहीं आया, मतलब एंटायर रो 0 और कभी नहीं हुआ, राइट? सो दिस इज माई क्लेम कि if there are repeated roots, we'll get multiple times entire row 0, but if there are not repeated roots, then we will get only once, okay? So वो अभी के लिए I am claiming and I think that is correct, but I'll check it up once and I'll whatever will be correct I'll find it and attach with this slide, okay?
ओके।
So उसके अलावा, but just 1 minute, like Abhishek was saying, another valid way is that also, like we can find out when we obtain a even polynomial, like any auxiliary polynomial, like row of zeros, then we can find the auxiliary polynomial, and if it is of low enough this order, then maybe we can directly compute the roots, and if that way we can find out, then also it works. But I am trying to find if completely from the Rao theory we can say whether the system is marginally stable or unstable. Yeah, someone else was asking something.
Sir, can there be multiple auxiliary polynomials in a characteristic equation?
Multiple auxiliary, yeah, there can be. Like suppose I have an even polynomial into an even polynomial. Okay, so that will give me a big characteristic equation. But first when we get an auxiliary equation, it will denote this one, and then when we get, it will denote this one. Okay. So we can get multiple. Like we saw in this case, if this is the thing, then we got multiple auxiliary polynomials. Okay? Is that correct?
Yes, sir.
Yeah.
Yes.
वन मोर क्वेश्चन सर, कि जैसे मेरा 2 बार रो जी हुआ तो मुझे 2 इक्वेशन, 2 एज वाली इक्वेशन मिला था, और दोनों एज वाली इक्वेशन को मैंने सॉल्व किया तो सेम रूट आया सर, मतलब फर्स्ट एज वाली इक्वेशन का 4 रूट आया सर, सेकंड का 2, तो दोनों ही सब को कंसीडर करके बोल सकते
नहीं समझ नहीं पाया। फर्स्ट का
होगा। 4
सपोज फर्स्ट एक पॉलिनोमियल आया,
उसका
Okay.
4 रूट है,
उसका 4 रूट्स है, हाँ ठीक है।
सेकंड का 2 है।
सेकंड का 2 आया, हाँ ठीक है।
ये तो हो सकता है दोनों में सेम हो या अलग भी हो सकता है। मुझे
नहीं
मतलब
सेम नहीं होगा, मतलब पहले जब एक रो ऑफ जीरोस आ रहा है, उसके बाद जो भी होगा वो सब रूट्स होंगे ऑफ दैट ऑक्सिलरी पॉलिनोमियल, ठीक है। तो पहले जो ये आया 4 रूट्स, फोर्थ ऑर्डर का ऑक्सिलरी पॉलिनोमियल, तो उसके नीचे का जो भी होगा वो इसी का ही रूट्स होगा। तो ये जो 2 रूट्स है वो भी इन चारों में से कोई 2 होंगे।
तो 4 मतलब यहाँ पर बोल सकते हैं कि यहाँ पर 4 ही और 6 रूट होंगे, 4 ही तो बोलेंगे सर।
4 ही बोलेंगे ना, हाँ
इसी में कंफ्यूज।
हाँ 4 ही बोलेंगे, मतलब ऑर्डर 4 का पॉलिनोमियल है तो 6 रूट्स नहीं हो सकते ना।
मतलब मेरा 5 डिग्री का था, मतलब कैरेक्टरिस्टिक इक्वेशन सर, तो एक उधर से राइट साइड है, यहाँ से 4, द टोटल हम नहीं बोल सकते 4 to 6, तो सिर्फ 4।
टोटल 4, हाँ या correct. So the general procedure was understood, right? What we want to do in a route array. I've noted one problem, like how to determine whether exactly when we get a row of zeros, whether it is marginally stable or unstable. So what I am claiming is what I told earlier, that if we get multiple zero rows, then that is a repeated root case and that will be unstable. But if you have non-repeated, like just one row zero, then that should not be a unstable polynomial. That should be marginally stable. That is what I claim, but I'll check it up and get back to you. Then yeah, so this procedure is clear to everyone, right?
हाँ ये सीखिए।
Okay. So I'll just move through the, yeah, someone was asking. Okay. So I'll just move through the further questions and see something that might be interesting. Just give me some more time.
सर वन मोर क्वेश्चन सर, जनरली हम लोग कहाँ पर गलती करते हैं सर, इसमें थोड़ा कुछ बता देते तो पहले से ही हम लोग
मतलब गलतियाँ कैसे करेंगे? Generic would be actually calculation mistake. That's all, because this is a very simple method. Like you get the polynomial, you write the coefficients, that's it. Then you compute the values. Then that's it. From the number of sign changes, you can clearly tell what is right half plane, what is left half plane, what is j omega axis, everything. So this is actually a very powerful tool. So yeah, I would say if you avoid calculation mistakes, you should be good with this. There should not be any other major sources of error. Okay. Yeah, so another type of questions that might come is like this. You have a characteristic equation given. How many poles does the system have with a real part -1? Okay. Or if there is a question like you are given a characteristic equation, how many poles are on the left side of s is equal to -2? Okay, things like that. So when that happens, so let's say this is f of s equal to this. Okay, I am taking f of s as the characteristic equation, characteristic polynomial. So now I want to find out how many poles does the system have with real part -1. So if the real part -1 is a pole, yeah, okay. So now if I define another polynomial as f of s -1, okay, I define this new polynomial. So original characteristic polynomial was f of s as given in the question. I take another new polynomial, g of s is equal to f of s -1. Now tell me, if there are poles on the j omega axis for g of s, what does that mean for f? Like if real part of s is equal to 0 corresponds to a root of this polynomial, that means f of -1 is equal to 0. or at least the real part of zeros of f is -1. Is this reasoning clear? I have f.
Can you repeat once?
Yeah, I'll repeat once. I have f of s, correct? That is given to me as the characteristic polynomial. Now I define another polynomial, say g of s, and I write it as f of s minus 1. Why minus 1? Because I want to check whether there are any poles on the -1 line. Okay, I want to check. This is the j omega axis. I want to check if there are any poles on this line. S is equal to -1. Okay. So for that, what I'll do is g of s is equal to f of s minus 1. Okay. Now, if g of s is equal to 0, right, whatever the roots might be of this equation, we'll solve that. Suppose there are like this, two roots, just two complex roots on the left half plane for g. Okay. So what that means is, this x, say this is -2 plus -2j, 2j, correct? So g of -2 plus -2j is equal to 0. That is what I have. But what is g? It is f of s minus 1. So I have -2 plus -2j minus 1 equal to 0. So that means f of -3 plus -2j equal to 0. So what I got was, if there are any poles on the left half plane for g of s, then those poles are on the left side of s is equal to -1 line for f. Okay. So for f we got them at -3 plus -2j. Here it was -2 plus -2j. So basically it is -2 plus -2j from this line. Okay. So again I'll just sum it up. I have f of s as a given characteristic polynomial. I want to find how are the poles distributed on the left, right, and yeah, Aarti, you have a question? Okay. So I want to find whether there are any poles, like how are the poles distributed on the left, right, or on the s is equal to -1 line for f of s. Is it clear till here? Hello? Am I audible?
Okay.
Yeah. Okay.
Yes.
So now what I am saying is I am defining a g of s. Okay, I'll just solve with this one. So I have, g of s is equal to f of s minus 1. So I'll put it s minus 1 whole cube plus 3 s minus 1 whole square plus 4 s minus 1 plus 2. Okay, so this is, I'll write it. This I have s cube plus s. Okay, so now you can see, okay, this one will, okay. So now see, when I solve this equation, I have s into s square plus 1 is equal to 0. That means s is equal to 0, comma s is equal to plus minus j. Okay, this part is clear till here. I just defined g of s as f of s minus 1, that is equal to s cube plus s. Then when I equate it with 0, solve that equation, what I get is this. Is it clear?
Okay.
Yeah, okay. So this is clear. But what that means for the original polynomial is, so g of 0 is equal to 0. Okay, that is one thing. Since s equal to 0 is a root of g of s, that means g of 0 equal to 0. But what this means is f of 0 minus 1 equal to 0. Is that not correct? Is it clear till here?
Yes.
It is clear? Okay. So that means f of minus 1 equal to 0. Right. So now similarly, if I write g plus minus j equal to 0, that means f of minus 1 plus minus j equal to 0, right? So the new polynomial that I found out, g of s, that is f of s minus 1, the number of roots it will have on the j omega axis equal to the number of roots f will have on the s is equal to minus 1 axis. Similarly, the number of roots that g will have on the left half plane equal to the number of roots that f will have on the left hand side of s is equal to minus 1 line. And the number of roots g of s has on the right half plane equal to the number of roots f has on the right side of s equal to minus 1. Okay? Is it clear?
Yes, sir. Number 4 का clear नहीं है.
अच्छा, okay. Okay, is it clear till this point कि the number of roots g has on the j omega axis is equal to the number of roots f has on the s equal to minus 1 line? Is that clear?
Yes.
Correct, na? So say some different polynomial is given, okay? F something is given. Say again I say g of s is equal to f of s minus 1. Then what do I have? F and say when I make the Raoult array for g, I get 2 RHP, 2 LHP and 1 j omega axis. Sorry. Say 2, 1, 2 j omega axis. Yeah?
Yes.
This is clear? So now
Yes, clear, sir.
g of s के लिए ये g of s के लिए है, ठीक है. तो हम देखेंगे we saw कि the roots on the j omega axis for g will correspond to roots for s for f on the s equal to minus 1 line. Correct? ये पार्ट करेक्ट है, समझ में आ गया? Yes. Okay. Now if I have a left half plane pole root for g, मतलब कि s is equal to say minus a plus say minus a, ठीक है. g of minus a is a root for g. Okay, that is the left half plane root for g. So what does this mean? f of minus a minus 1 is equal to 0. है कि नहीं? So what it means is this minus a minus 1 is a root for f. Right, minus a minus 1, not minus a. So basically whatever is the pole chart, say I have like this, like this, like this, like this, whatever it might be, for g of s, right? Say for g of s I have like this. Okay, g of s. Now for f of s what I'll have is, there is this s equal to minus 1 line. Basically the s is equal, the j omega axis is translated to s equal to minus 1 for f. So we'll have something like this. Say this distance is 2, then this will be 2, and this is say 3, then this will be 3, so on. So basically it will, the j omega axis for g will be translated to s equal to minus 1 for f. Okay, so this actually you can solve for yourself. You can take as many polynomials and try it out. Take some f, then find g of s as f of s minus 8. Okay, then you solve the Raoult array for g. Whatever pole, however it is distributed for g, similarly it will be distributed for f, but around the s equal to minus a line. Okay, so you can try it out for yourself. You'll feel more comfortable in understanding this concept. But I hope you have, yeah. So basically you can check this part. at least you are confirmed with this case, right? That g equal to 0, whatever root I have, that means f of minus 1 plus that root is equal to 0. Okay, yeah, basically you can try it out and check. So I'll solve this question once. Okay, I'll solve this question. I had this is f of s. G of s I am saying it is equal to f of s minus 1. Now what I'll do is, how many poles does the system have with real part 1? I'll solve for g of s. We saw that it is equal to s cube plus s. Now I'll solve for g of s is equal to 0. That means s is equal to 0 comma plus minus g. Since g has 3 roots on j omega axis, that means f has 3 roots on s equal to minus 1 axis. So that is the thumb rule that we'll have. So for any f, I have x LHP. So I have f, I find out g is equal to g of s is equal to f of s minus a, right? If this has x LHP, g of s, I am talking about g of s. It has x LHP, y RHP and z j omega. Then f of s will have x poles on the left side of s is equal to minus a line, y poles on the right of s is equal to minus a line, and z poles on s is equal to minus a line. That is the main takeaway of this question. So you can try it out, you will figure it, but the rule of thumb is, you have f, you want to find the number of roots on some particular line. The way to do is, you take a g as such and solve it, you will get the pole distribution for s. Okay, so I hope that I could make it more clear, but I think this question you will understand better only after solving some more. So with that I will conclude for today's session. And
सर अगर कोई ओरिजिन पर रूट है सर, एक लेफ्ट साइड और एस प्लेन है, तो वो सिस्टम अनस्टेबल ही होगा सर?
सॉरी एक ओरिजिन पे है और
एक लेफ्ट साइड ऑफ एस प्लेन है.
See, this is actually a little controversial topic, but s is equal to 0 अगर है, तो by definition of Weber stability, you would say that it is unstable, correct?
Yes.
क्यों? क्योंकि if you have s equal to 0, that is say you have 1 by s, and say you give 1 by s. Okay, 1 by s is a step input, it is bounded. So when you give that into the system, what you will get? 1 by s square. But this is a ramp input which is unbounded, right? So you are giving one bounded input, you are getting one unbounded output. So that is enough to say that this system is Weber unstable, right? So if you have s is equal to 0, you should say that the system is unstable. So with that I will conclude for today. We will continue again next week with week 5's course content. I hope I am able to help you in some concepts, and maybe I have not confused you much with this one, but I am pretty sure if you will try it out with some polynomials, you will see how you will take some random f, take it such that you can solve it manually, like either second order or third order. Take some f, take some g as per any translation, and see what are the poles of f, what are the poles of g. You will get a clear relation between them. So with that I will conclude for today, and we will meet again next week, same time. Thank you.
Thank you.